Do you run a web application or web service? You probably do a couple things to optimize the performance of your site. You make sure that the database responds quickly and more. But did you know a well of performance improvements actually lives inside your web servers themselves? Join Ben Kane and me to discuss how to optimize your Python web application as well as MicroWhisky and Nginx. This is Talk Python to Me, episode 143, recorded December 11th, 2017. Welcome to Talk Python to Me, a weekly podcast on Python, the language, the libraries, the ecosystem, and the personalities. This is your host, Michael Kennedy. Follow me on Twitter where I'm at mkennedy. Keep up with the show and listen to past episodes at talkpython.fm and follow the show on Twitter via @talkpython. This episode has been sponsored by Rollbar and GoCD. Thank them both for supporting the podcast by checking out what they're offering during their segments. Hey everyone, before we get to the interview, I want to share a quick update about our Python courses with you. Do you work on a software team that needs training and could really use a chance to level up their Python? Maybe your entire company is looking to become more proficient. We have special offers that make our courses here at Talk Python the best option for everyone you work with. Our courses don't require an ongoing subscription like so many corporate training options do. And they're roughly priced about the same as a book. We're here to help you succeed. Send us a note at sales@talkpython.fm to start a conversation. Now, let's get to the interview. Ben, welcome to Talk Python.
Hey, thanks, Michael. Thanks for inviting me.
It's great to have you here. I'm just a sucker for a good performance talk. So I'm really excited to talk about all the different layers of Python web apps and performance tuning, mostly outside of the Python code itself, right?
Yeah, well, I would say one of my keys is you have to tune pretty much everything, the entire stack. So Python code, absolutely, but it's not just that. And that's a real important thing to remember is it's everything, because everything matters.
Yeah, absolutely. So it's going to be great to dig into that. But before we do, let's get to your story. How did you get into programming in Python?
In the 90s, when I was a teenager, I was making anime fan sites, which is fun, just for fun, using HTML, CSS. And I wanted to really kick them up a notch. So I learned PHP. And that was, kind of the web framework at the time. And I did a little bit of that for fun, mostly, some for money. But it's funny, in my adult life, I didn't actually make a career out of it. I went into retail. And then it wasn't until a friend said, dude, what are you doing? You can make these awesome sites. Why don't you make a career out of this? And I kind of thought about it. I was like, oh, he's right. I should make some money out of this.
This is way more fun than what I'm doing.
Exactly. So fast forward and here I am.
Yeah, that's awesome.
Yeah.
Cool. And what are you doing day to day these days?
I'm a staff engineer at American Express. That's essentially the payment network for American Express. So the way I like to summarize it is it's really the yes-no machines. So when you swipe your card, that transaction has to get somewhere. And that's somewhere to say yes and no. All of those systems that it goes through in order to get to that yes and no, that's essentially what I work on every day.
Wow. So a lot of services, a lot of low latency demands, right? The person is standing there with their card, oddly, uncomfortably looking at the cashier who's also uncomfortably trying not to look at them, just waiting for your systems, right?
Yeah, exactly. And a whole bunch of them too, right? Because it's not just that one person, it's millions of people around the world.
Yeah, when you think of the number of people shopping and swiping cards and just using payment at any given moment, it's huge, right?
Yeah, and then when you add things like Black Friday, Cyber Monday, all those big shopping holidays, it's huge, right? You have to...
Does that make a big dent for you guys?
Oh, yeah. The more people are shopping, the more they're swiping their card, the more our systems have to be there to say the yes and the no.
A lot more yes-no questions, huh?
Exactly.
Yeah, nice. So when you talked about the PHP stuff, I kind of distracted you from the Python part of it.
With Python, I was actually working at a web hosting company as a sysadmin in about 2005. Back then, Perl was really the language of choice for sysadmins. And my buddy Marcel introduced me to this new language called Python. And from then, it was like love at first sight. I loved it. I loved the syntax of it. I loved how easy it was to work with. But then, of course, I moved to a Perl only sysadmin shop. So I was the only one who knew Python. Everyone else knew Perl. So I was kind of like, all right, well, I guess I'll just write stuff in Perl if I have to. I was really a big fan of Python at the time. So I really didn't do much with it then. And then about 2013, 2014, I realized, I was at Amex at that time, I realized that the traditional sysadmin role was kind of dying off. And I would say at this point, it's pretty much dead. It's just not everyone knows it yet. Yeah, wow. I think it's that much of a change lately.
Yeah, so like DevOps and stuff like that is kind of replacing it, Ansible and SaltStack and.
Oh yeah, exactly. And if you want to stay relevant, I figured you got to learn how to program. And that's when I really buckled down and learned how to program again above like scripts, right? I've been writing scripts forever, but more than just a script. And there's a big difference between the two. And of course, Python was my language of choice to do it.
That's really cool. So how did you get interested in performance tuning and that kind of stuff?
It's really part of my job. With things being the authorizations and that yes and no, like you said, people standing at a terminal waiting for an answer. We get a lot of requests, and these requests have to be very, very fast. So one of the things that we're very acutely aware of is performance. And we actually hold ourselves to certain performance benchmarks, and we constantly do performance testing during the development cycle just to make sure that we're meeting those benchmarks.
Do you have like performance requirements or measures in, say, an automated build or anything like that?
Yeah, but that's more for developer satisfaction, right? But for us, it's more about how fast those transactions get processed. When I think performance tuning, that's my immediate thing. Of course, everything else that goes along with it is important, but to me, like that's the thing that shines so bright in that. The cool thing is you can take what you learn from that and apply it to all sorts of different tools.
Yeah, absolutely. And as a sysadmin DevOps person, you see these as the whole system, right? Like
exactly.
Linux plus the servers and services plus the app. How does that thing work, right? Or maybe even across, right? Like how does the front end web servers plus the load balancer plus the back end services, how does that thing perform is really more what you might want to have like the final measure be, right?
It all matters, right? So you have to really look at the whole picture in order to see how things interact or how things change the performance of a system.
Absolutely. So one thing I kind of wanted to touch on just a little bit at the beginning here is there's a little bit of a difference between scalability and straight performance, right?
If you kind of think about scalability and performance, a lot of times they're really two separate problems, but I do think they're very closely related. With scalability or performance, you might say like one request versus a million requests. And with performance, it's not just necessarily one request, right? You might also have a whole bunch of requests. Maybe it's not a million, maybe it is, in one instance of an application. And you need to be able to see how many concurrent requests can I handle, because that impacts performance overall.
Yeah, one of the things I think is kind of funny to think about is you could have an app that responds like it takes 10 seconds to process a request, which sounds like performance sucks. But maybe if you throw a million requests at it and it only goes up to 11 seconds per request, that's a pretty scalable app. It just doesn't perform very well, right?
Yeah, exactly. You gotta make that thing faster, right? But scalability is also, you can talk about scale up and scale out too, right? You can scale out the number of instances. So, if let's say your application can only handle a couple of thousand requests at a time, by adding additional instances, you can add that many number of requests at a time. But then there's other trade-offs with that too. You add complexity to the application, which that's a trade-off not only in performance and scalability, but also with availability. And that gets a little tricky as well.
Yeah, and some people can get away with like very small amounts of lack of uptime and availability. I suspect you guys not so much.
Yeah, not at all, really.
It's frowned upon to have the yes-no machine down?
I don't know why. I mean, it's highly frowned upon to have that down. We go through a lot of effort just to make sure that it's up all the time.
Yeah, I'm sure. But it totally adds more complexity, which we'll talk about. So I guess one of the things to think about is the difference between performance testing and performance tuning. Could you maybe compare this for us?
Performance testing, at least in my mind, although I think many would agree with me, performance testing is really just the execution of tests that measure performance. Performance tuning is more of a concerted effort to improve performance. So, to give an example, in our development process, we have automated performance tests that run all the time. We know whether that benchmark is being met or not. But really, performance tuning is adjusting that benchmark. Is that benchmark now a higher benchmark? Does it need to necessarily go lower? Although generally we never go backwards, we always go forwards. You only go backwards if you really have to.
Right. Maybe you add some major feature and it's worth it, but it does make it go slower because it's doing more or something. Yeah.
Yeah. All of these things are about trade-offs. You gain in one area, but you trade in another area. So yeah, it's very important kind of know the difference. Really, the concerted effort with performance tuning, that's important. If your goal is to really squeeze every microsecond out of an application, it's important to have that concerted effort. And it's not just about what's the measurement tool telling us.
And if you have graphs or some other kind of reporting, it's really nice to actually go, wait a minute, when we deployed that new version yesterday, what's the response time now than what it was before, or memory usage now, or whatever?
Yeah, measurement from production is huge, right? Because you can run all the tests you want in kind of pre-production environments, but production is where things get crazy. And if you start seeing differences in performance there, it really gives you an indication of where you need to start looking as well. And it's a really good idea to just measure both, measure your pre-production environments, compare that with your production environments and see where the differences lie and why they are different.
Yeah, absolutely. Production, that's where reality lives, right?
Exactly. That's what really matters at the end of the day.
Exactly. You're building this stuff to run it for millions of people in production. Like, it doesn't matter what your tests say. Like, that's the final arbiter of how it is.
Yeah.
Yeah. So before we get farther into it, let's maybe take a moment and just talk about what a typical web stack in Python looks like.
Really, if you kind of start at the top, you have something like Nginx, which is a web server, and I'm actually skipping a whole bunch of layers, but we'll kind of talk from the web server down.
In one web server, maybe we're not talking about the scaled out architecture with all the machines working together, right?
Exactly. So in your typical one stack kind of approach, you have your web server, you have things like Nginx, Apache, there's several others. Nginx, one being known for being very performant out of the box. And really what those do is they serve those, HTTPS requests, they serve kind of the static content, and you can even do some like caching with them as well, which is interesting. And then you go to like your application server, you have uWSGI, gUnicorn, things like that. And those are really there for being the worker processes for your running application. So they'll start the application, they'll manage the application, make sure it's running, and really make sure there's enough workers of that application to handle those requests. And then, of course, you have your app framework as well, your web app framework. So Flask, Web2Py, and then Pyramid, Django. There's a whole bunch of those. All of them are kind of a little bit different. Some have different areas of expertise, and some have more features, some have less features. One of the interesting things with performance, if performance is a big factor for you, one of the kind of caveats, or one of the more golden rules I have is the less features, the more performant it's going to be. That's not always true, but it's a good general rule of thumb at least.
Yeah, the less you're doing, the more you can do of it. Yeah, that's for sure.
And then you also have the database, and that's another whole factor to think about, and whether it's SQL, no SQL. Not every web app is going to have that, but a good chunk of them will.
Yeah, most of them will have some kind of data store, and usually the choice of the database. You actually have some really interesting things to say about that. We'll talk about that. One thing I do want to maybe take a step back and talk about, because I think it's important to understand for people who don't live in web deployments all the time, is you talked about two web servers. You talked about Nginx, and you talked about MicroWhisky or uWSGI. And why do we need two?
That's actually kind of important. And I think I will simplify it with Nginx is really good at what it does. It's really good handling some proxying. Let's take an example of HTTPS. In order to do that SSL handling, right? The SSL handshakes, the decryption, all of that. Leveraging Nginx for that is very fast. It's good at that. It does that very well, and it does that very fast. And it's tuned specifically for that type of task. It also is really good for serving static content. So if you take an application server like uWSGI, that's running your Python web app. Well, if you have static content with that, offload that kind of workload to Nginx, let Nginx do the static content because that's very static. It doesn't need to talk to your Python app. If there's no need, then don't do it. But uWSGI is more for executing the requests across your Python application as well. And that's really kind of your worker process. Now, there's many ways to set up this type of stuff. You can do things in many different ways. Some things work better. Some setups work better for certain environments. But your typical deployment's going to have kind of all three: web server, the application server, and then that web app framework as well.
Yeah. And one of the things, I don't know how much MicroWhisky suffers from this, but certainly the Python web servers themselves, the pure Python ones, can suffer from the fact that you only have the global interpreter lock, the GIL. So you can really only do so much serving on any one thread at a time. And if you're busy serving up like a large image file, you're not processing requests, right? Like, so putting something in there to like offload everything except for the true application requests like Nginx is, I find this pretty awesome.
That's what Nginx is good at. So let it do its job.
Yeah, and it can be like a load balancer or a proxy server. It's really quite advanced what you can do with Nginx.
You mentioned running it all in kind of one server or one kind of instance, but that's exactly right. You can put Nginx up one level and have it do the load balancing across multiple backend applications. And that's really powerful as well.
Yeah, that's awesome. Another thing that I do at the Nginx level, at least on my sites, is that's where all the SSL exchange happens, right? Beyond that, like the MicroWhisky stuff, it doesn't even know that it's encrypted. Well, I guess because it's not, but it's in the data center, right?
Exactly. Although even today, that sometimes you're starting to see even that that layer get encrypted as well. Things change over time.
Yeah, I can see. And the more machines you involve, the more encrypted it is. I guess in my setup, I have MicroWhisky and Nginx on the same machine, so it's like local loopback. So encryption doesn't make as much sense. This portion of Talk Python to Me has been brought to you by Rollbar. One of the frustrating things about being a developer is dealing with errors. Relying on users to report errors, digging through log files, trying to debug issues, or getting millions of alerts just flooding your inbox and ruining your day. With Rollbar's full stack error monitoring, you get the context, insight, and control you need to find and fix bugs faster. Adding Rollbar to your Python app is as easy as pip install Rollbar. You can start tracking production errors and deployments in 8 minutes or less. Are you considering self-hosting tools for security or compliance reasons? Then you should really check out Rollbar's compliant SaaS option. Get advanced security features and meet compliance without the hassle of self-hosting, including HIPAA, ISO 27001, Privacy Shield, and more. They'd love to give you a demo. Give Rollbar a try today. Go to talkpython.fm/Rollbar and check them out.
If you look at like uWSGI, that one in particular is good chunks of it are written in C, right? And that can also help with performance because, it's C. C is very fast. C's precompiled. It's got performance in its nature, right? So being able to leverage that is also very useful. And Nginx is also written in C. And there's kind of that, you used your image example. It's a really good example, right? That's where you can leverage that aspect of Nginx to really get that boost of performance.
Right. The threading and parallelism, that's all runs over there in C. And I'm glad I don't have to maintain that.
Yeah, I would agree with you on that one.
Let's start by thinking about how you might approach performance tuning. Like, I've got an app. It's kind of working pretty well, but certainly could be better. Maybe under times of load, it's like too slow. Or I'm just thinking, 300 millisecond response time is fine, but could we do 25 instead? But how do you think about this tuning problem?
I like to think of performance tuning as if it's a science experiment. So first step is put on a lab coat. And Then kind of after you got your lab coat established, really, kind of start with the observation. Now, I would say one of the keys here and kind of the next step, which is creating questions. With your observations and your questions, it's really good to have as many perspectives as possible. You mentioned kind of the Linux stack, you have web servers, you have application servers, you have the actual Python code itself. Many times in many areas, some of these things are managed by different people, and bringing those people in to kind of add their input into observations and what kind of questions can be asked, what kind of knobs can be turned, you really start to get multiple perspectives, and that's where things get very interesting. Now, with the same thing with science experiments is you only want to change one thing, and then kind of that's important as well. So as you're testing and you're validating and you're kind of adjusting as necessary, only making one change at a time is very important, because otherwise, if you make too many changes at a time, and this is a real common mistake I see, if you make too many changes at a time, you get a difference, but you don't know which thing caused that difference. And sometimes that leads you down like a rabbit hole, right? You start chasing something that you thought made a big difference, but in reality, it was something completely different. And that's really important.
Yeah, or one change made it faster and one change made it slower, but you did them at the same time, so it looked like it had no effect.
And another key piece is really establishing your baseline. And that's one thing I really talk a lot when I'm telling people about performance tuning is the first thing you do before you make any changes is establish a baseline. And then you also establish a base between changes. So usually when you have a big performance tuning effort, you're not just change one thing and then everyone goes about their day. You want to change multiple things. You want to have some fun with it. You just want to see all the little knobs you can turn to make this thing go faster, right? So being able to stop and baseline between each kind of iteration is important. And also being able to go back to a previous state. It's important to test things individually and together in kind of separate tests. And it can take longer, and that's complicated, and people tend to want to rush through when they're first kind of getting started with performance tuning. And you just got to take your time, and it's key to really measure it very well.
Well, and with these deployment stacks, or what do you want to call them, you've got Nginx, and you can tune Nginx. You've got MicroWhisky or G-Unicorn or whatever. You can performance tune that, and you've got your Python code. And so measuring them separately, I think, can be a little bit challenging. While you're talking, it occurred to me that it's pretty easy to measure Nginx directly, maybe against a static file. If you have your app running in MicroWhisky, you could just start hitting it. You showed for both of those scenarios, you have AB, Apache Benchmark, right?
And Apache Benchmark is actually comes with like the Apache 2utils package, and it's a very common benchmarking tool. I would say it's got its own problems. There's some things it does really well, some things it doesn't do, but it's a good general purpose tool. Another one I'm a big fan of is GoBench. It's written in Go. It's a little bit different. It approaches benchmarking web requests a little bit different. In some cases, I've seen it faster. And that's actually an interesting problem too, is these benchmarking tools are applications in themselves, and they're running in environments themselves. So often you can run into situations when your application is tuned so well that your benchmarking tool is actually where your bottlenecks are. And that gets like into a real interesting problem.
Yeah. So do you recommend running the benchmarking tools on a separate machine with like a super low latency connection, like in the same data center or something?
Yeah. Sometimes we've just daisy chained servers to get that low latency connection. But yeah, absolutely. If you can run it on a different machine, that's awesome. That's great. You should do that. Sometimes though, in order to really cut out network latency, we've had to either run it on the same machine or like I said, daisy chain some servers so that they don't go through any switches on the way.
Yeah, it can definitely. It's a complicated problem, right?
I think it's fun because you get to learn all of these cool little why things work. And the why things work is important. And I find that fun because you learn more about it. And as you learn more about it, you also say, well, okay, if this knob turns this way and that causes this because it does this, what if we turn this other knob?
Well, I feel like learning about all the knobs and experimenting with them actually helps you understand really what happens when a request goes through your infrastructure. Because it's easy to go, this is the config file and I put it up and then it works. But knowing more about the actual steps before it hits your code is actually pretty interesting.
Yeah, and that's important for 3 a.m. calls as well when you have a problem, right? So the more you know kind of about your application, some of the benefits to really performance tune your application is that this is why it works and this is how it works. So finding problems is a lot easier. But that also really plays into getting even more performance out there. The more you know about your application, the more you come up with ideas on what to experiment with and where to make those changes and how they would affect it. Now, I would say, and this is one of my key points, is when you are approaching performance tune, kind of circling back there, is don't get too hung up on a single solution. As you are measuring things and you think this is going to make a major impact, sometimes it doesn't, and sometimes it actually makes things slower. I've had that happen quite often. In fact, I'm not sure if I can think of a single major performance tuning effort that we went through that we didn't have an idea of one thing and we're like, oh yeah, this one thing is going to make our application just scream, and it had the complete opposite effect.
Yeah. So that's a really good point. Thinking about, how good our intuition is around performance is. And so one thing I wanted to sort of wrap that up with though is you have AB and you have GoBench, and you can test your server level things. But if you actually want to test your app in isolation, you maybe don't even want to use the development server. You want to just call it directly. And so you could do things like time, say, a unit test, or profile a unit test, or something where it's literally just your code running and there's nothing in between.
So that gets into like kind of code profiling, right? And Python comes with C profile and profile. And what those are built-in profilers. And what they really let you do is, it's as simple as running, python-m, C Python, and then a Python file. And what they'll do is they'll actually let you see what operations are occurring and how long they take to occur. Now, an interesting thing is when you do profiling, sometimes that also affects changes in performance as well. So you have to take some things with a grain of salt, but it is a really good way to kind of look at the execution of what's happening underneath the covers of all that code. And it helps you to really kind of isolate where within the actual application itself you might make some performance improvements.
Right. You do have to be a little bit aware and cognizant of the sort of observer effect, sort of quantum mechanics style, right? Like it was doing one thing until I observed it, then it did another thing. Darn it.
Yeah, and the same is true with monitoring and production as well. I've seen several times where maybe you make this method of monitoring performance statistics, but in doing so, you actually create a load on the system, and that load then starts potentially affecting performance in itself. So it's all about balance. That's kind of like a key thing. And you have to look at these things. Sometimes it's worth it and sometimes it's not worth it. And you really kind of have to take a look at your application, what you're running, and what those trade-offs are. And there's no real hard line way to say this is worth it or this is not worth it. It's all very situational. It depends on the application. It depends on the environment and what's actually happening.
For sure. One final thing on this profiling bit that I wanted to throw out there is I'm pretty sure some of the other frameworks have something very, very similar, but in Pyramid, it has this thing called the Debug toolbar, which lets you analyze the requests and see what's happening. And it has a performance tab, and you can check a box and it'll actually collect the C profile performance data as you click around the site on a page-by-page basis. And that's really nice to just drop in and see, okay, this page is slow because what? Just go request it and then flip tabs over to the other thing.
That sounds pretty cool. I'm a big fan of Flask, so I haven't really given Pyramid a try, but That sounds very interesting. I'll have to check that out.
Yeah, it is pretty cool. I'm a fan of Flask as well, and I think Flask has some kind of debug toolbar, but I don't know if it has the profiling built in because I just haven't done enough with it.
Yeah, I haven't looked in that.
Yeah, another thing that I feel like is often, maybe this is my perception from the outside, and it's just like I'm looking at this like, oh, I know the database for this site sucks. I know it. That's why it's taking 5 seconds to load this page. I just do. And so I feel like a lot of people skip the real optimization around the database stuff. Like indexes, like if you have a query that doesn't use an index, you need a really good justification for that, for example, in my mind.
Yeah, absolutely. And when you talk about like your traditional SQL databases, although some NoSQL databases have indexes as well, when you talk about your traditional SQL database, indexes are incredibly important. And think about what they do, right? And this is kind of goes down to knowing what is underneath the covers of every little piece. If you think about what an index is a database is an application in itself, right? It sounds like this ominous thing, but at the end of the day, it's just an application. And really, indexes are a way for the database application to know where on disk am I most likely to find this data. It's a very fast way to find one little piece of data that then leads you to get all of the different data you need. If in SQL talk, it's really, where's this index key? Let me find that key, and then boom, here's all my row of data. It really helps with performance. I would say indexes are very important as well, but sometimes it's also queries. Sometimes queries can be very, very complicated, indexes or no indexes, and simplifying some of your queries, simplifying some of your database structure can really help out with performance as well.
Right. And maybe your queries are terrible because your models are not quite right in your database. There's like all sorts. We can't go too far down here, but I think optimizing the database is something to consider, right?
Yeah, exactly. And one thing to remember is, the database was modeled at the beginning of this application, but in reality is most applications grow over time and the usage grows over time. So sometimes those queries get the way they get because, well, we wanted to change and have this ability to pull this data over here, but we didn't want to make major changes to the database model. And sometimes it's just necessary.
Yeah, for sure. So you wrote a really interesting article called Eliminate the DB. I don't want to go too deeply into it, but you had some really interesting ideas, and I definitely want to point people at it. Maybe give us the flyover on that.
Really, it's eliminate the database for higher availability. And it's a bit of a trolling title, to be honest. A lot of DBAs internally did not like me for that post. But really what my point is when you're creating a highly available application and highly performant application, the goal is to minimize complexity because complexity leads to problems. The more complex an application is, the harder it is to troubleshoot, and not just an application, but an environment in total, right? The harder it is to troubleshoot, the more opportunities for failure are there. If you just have an application and there's no database, a database going down doesn't affect that application, right? But if both are there, you have 2 failure points versus 1. And that's, really kind of what the article is all about, is kind of calling out that if you're going to use a database, make it worthwhile. Don't just use a database just to use a database because it's easier. That is often kind of really what the design pattern is all about, is only use a database if it's absolutely necessary. And that's really only when you're talking about super high availability environments. Some environments, it doesn't really matter. If it's easier to use a database, then use it.
You've got that web app, you've got the database, they talk to each other. Maybe they're even on the same machine, maybe.
Exactly. And sometimes it's fine, but other times it isn't. And really what that article was all about is knowing when to think about, should I or shouldn't I include a database in here?
Yeah, I liked it because it made me think, like, at first, like, no, that's not possible. And then I'm like, all right, so how is it possible if I think the answer is that you can't do it? Do you know what I mean? Yeah, it's pretty cool.
And it all depends on use case. Some applications, it's completely not possible. And other applications, it is. And I'll give you a really good common example, not even like card related, is, my personal blog is actually a statically generated HTML. Now, that doesn't mean I write in HTML. I write my blog in Markdown, and then I use Python to take that Markdown and generate HTML. Some blogs, like if you look at like WordPress, for example, that's got a database backend. Now, my static HTML is going to definitely be a lot less complicated to run than a whole web stack just to write a blog.
Right. You might not even need a server. You could potentially drop it on like S3 or something.
Yeah, exactly. You can get real interesting once it's static pages.
Right. Absolutely. All right. So there's a lot of stuff we can do at the architectural level, caching, queuing, async IO, changing the runtime to say PyPy or Python or something. But I want to make sure we touch on all the stacks at a pretty good level. So maybe let's move up one level into MicroWhisky and say, this is the thing that runs your Python code. What are the knobs and levers that we can turn here?
There's quite a few. One of the simplest ones is actually enabling more threads. So threads are interesting because you can actually go too far and have too many threads, or also go too few as well. And really what that is if you look at that configuration, it's processes equals a number. So one of the things that you kind of want to look at is how many CPUs does my actual machine that I'm running this on have? And that's your production machine, not your development machine, because those are two different things. And sometimes you have to also adjust for the environment as well. And that's something to kind of think about when you're thinking about performance tuning things is what's it run on my laptop is going to be very different than how things run in production. In production, you might have a machine with a whole ton of CPUs available, and on your laptop, you only have, maybe 4 or 8, right? Depending on your machine. And then another thing, so kind of the golden rule there is try not to exceed the number of processes for a CPU. But I have found in some cases, in some workloads, you can actually go up to twice of it and still get a performance increase. It's kind of interesting. It's really one of those things where you got to adjust the number and slowly adjust it as you go. Start from the lowest and work your way up, or potentially work your way down if you've already got something deployed and it's starting to hit some interesting areas.
Yeah, it gets really interesting too, because basically the parallelism of that is tied to the parallelism of Python, which has its own interesting mixes, right? And so if you're doing something that's computational, that takes really long, right? Like it doesn't have to be science. It could be generating a really large RSS feed, for example. Some of us have experience with that. And yeah, the RSS feed for TalkPython is like 700K, and it's quite a bit to generate it at this point. At some point, I may have to do something about it, but it's hanging in there just fine. But that kind of stuff, that kind of locks that process up, even with the threads, right? But if what you're doing is like, I come in, I process requests, I call a database, I wait, I call a web service, I wait, and I give it back. That one can keep flying because those network IO things kind of break it free, right? They release the kill. And so it gets really, I think it also depends on how your app is working. What kind of app are you running there?
You're exactly right. One thing I actually want to call out, just to circle back a little bit, is there's kind of two adjustments you can make. By default, uWSGI processes all have the same CPU affinity. So if you do have like a 2 CPU machine, for example, just changing the processes to 4 will actually lock all 4 of those to the same CPU. But if you enable threads equals 2 or enable threads equals true, what that'll actually do is that'll actually split the processes across multiple CPUs. And that's actually a very common problem that people run into when doing multi-threading, is they run into like, oh, well, I'll just add some threads and we're good to go. But how it actually lays out in the stack is a little bit different. Linux tries to get things running on the same CPU as much as possible to really leverage things like L2 cache. But there are ways to split it out to multiple CPUs, and sometimes that can really be a big benefit. But
yeah,
depending on what the application does, the reverse can be true as well, where running on that same CPU can give you that performance benefit as well. And like your RSS example, I would say because you're kind of looking all at the same data and generating it, you might even get a benefit running that on one CPU versus 2, right?
Yeah, for sure. This portion of Talk Python to Me was brought to you by GoCD. GoCD is an on-premise, open-source, continuous delivery tool to help you get better visibility into and control of your team's deployments. With GoCD's comprehensive pipeline modeling, you can model complex workflows for multiple teams with ease. And GoCD's value stream map lets you track changes from commit to deploy at a glance. Say goodbye to deployment panic and hello to consistent, predictable deliveries. We all know that continuous integration is super important to the code quality of your applications. Choose the open source local CI server, GoCD. Learn more at talkpython.fm/GoCD. That's talkpython.fm/GOCD. You have an example in this. There's an article that you wrote about optimizing MicroWhisky or uWSGI, and you have one for Nginx that we'll talk about as well. And you start out as your baseline in this one at 347 requests, and just that change knocked it up quite a bit to 1,068, which is quite the improvement.
Yeah, it is. And that's as simple as going from one CPU to two. So
yeah, exactly.
it seems like, math would say, well, if I have two CPU and I'm getting 347, shouldn't I get around 600-800? So, I mean, 600 to 800 range. Sometimes you can even go a little bit higher, right? With you have less contention. Another thing to kind of think about with Linux is there's a task scheduler, right? And this task scheduler is figuring out what processes should I give priority to CPU time. And when you're all running on a single CPU, you also have other processes that are running against that single CPU. So you're going to have conflicts in CPU time that the task scheduler's job is to figure all that out. So having two kind of allows you to reduce some of those task scheduler conflicts as well.
Yeah, it's pretty interesting. So the two other major things, one of them I think is somewhat obvious. One of them is sort of counterintuitive. One you say is to disable logging, which you may or may not want to do that based on you might want to have logs for certain reasons. But if you can, disabling logging actually has a pretty significant performance change.
Yeah, because that's disk IO essentially. So every log message, and there's many ways to solve this problem. In my article, I kind of took an easy approach by just disabling it because it was an article and it was easy. But really what the root of that is by disabling logging, I'm telling, MicroWhisky to stop writing to disk, essentially, for every request. So for every request by default, it's just going to write to disk details about that. And whether it's asynchronous or synchronous, and those do matter a lot. Some platforms will default to kind of synchronous logging. And what that is it makes sure that that data is written to disk before kind of going to the next step. And asynchronous is more like, well, let's throw this in a buffer. Let's kick off a thread to write these to disk and let things kind of continue. Those can be huge. Just going from synchronous to asynchronous can be a big performance increase, but nothing will give you better performance than just disabling it. But there's some trade-offs with that, like you said.
It's hard to optimize faster than doing nothing.
Yeah. One little tip I tend to like is actually using syslog with UDP for logging instead of going to disk. So syslog is a very well-established protocol. When you're using UDP, you don't have to worry too much about like TCP handshakes. It's kind of fire and forget. So pushing that to a network place versus disk, which, disk is traditionally slow, although solid state drives have made it a lot faster. It's still slower than, memory, and going to kind of that network stack can make a big difference. And that's kind of an interesting trick. You don't necessarily lose your log data, but you also, don't have to go to disk. But another kind of key one there is make sure you're not writing too many log entries. Kind of finding the right balance of how much logging is there is really important. Now, when you're using a framework, the framework's going to do what it's going to do. But even within your application, the less logging, the better. But at the same time, you have to have this kind of minimum amount of logging in order to support it.
Yeah, absolutely. So the last one that I said was non-intuitive is you can tell the worker process to live only a certain amount of time, and after that time, to just be killed off and basically start fresh again, which there's some, startup costs, and there's like
Absolutely
some cost to having this new process come up, and it reads like your template files potentially or whatever. So it seems like that would be slow, but you actually flipped it to something like restart the worker process every 30 seconds, and it was quite fast.
That really depends on the application. If your application is going to hold a lot of data in memory, that could be good or bad, right? Depending on how things start up. If you have to kind of load things in memory before you can really start serving requests, then that startup time really, that's a hit, right? But if your worker process is really just executing something very fast, restarting it, as long as it kind of starts up very quick and you have a very low startup time within the actual application itself, you can get a big benefit. The example I had was a very simple application. There wasn't a whole lot of kind of data stored in memory or anything like that you had to kind of build up. So the start time was really small, and that's where I kind of got that benefit. But again, it all depends on the application.
Right. And the benefit can be the lack of memory management or simple allocation because the memory is not fragmented. One of the things that pretty sure it was Instagram did, that was a super counterintuitive for performance, but at this level is they turned off the Python GC. They left only the reference counting bit, but that doesn't handle cycles and stuff. So there's definitely memory leaks when you do that.
Yeah, but if you restart enough.
Exactly. You just go, it's our workload, our data. That means we can run for 6 hours before we run out of memory. So let's just restart every hour, something like that. And they got like 12% improvement or something. I mean, it was really significant.
That goes into kind of the overall architecture, right? Sometimes it's okay to kill off an application as long as you're doing it gracefully and as long as you have others to take its place, right? And that's kind of where that whole microservices approach really lends a hand, because if you break things down really small, then it's a lot easier to run multiple of them. So you can actually handle the distribution of load to other processes when these ones you want to start taking them down, right? And that's where
for sure,
having like Nginx up front doing some of that load balancing really plays into a big hand in that.
For sure. So let's talk about Nginx. We've sort of said what it is, but just like before, you had this baseline analysis. In this case, you had a little under 3,000 requests per second, which this is to like a static HTML file or something like that, right?
Exactly.
Yeah. So it gets all the other stuff out of the way. It's not to the app. It's just to serve up a thing. And so the first thing that you said that you might want to look at is worker threads.
Again, that's just like with MicroWhisky, right? That's really the number of processes on the system. So a real interesting thing about Nginx is by default, it's actually at auto, which tells Nginx to create one worker thread for every CPU available to the system. Now, what I actually did was I changed it to 2. So actually, no, I changed it to 4. I had 2 CPUs on the system, which is basically 2 worker threads per CPU and 2 processes. And I actually got a pretty good boost out of that. And it wasn't too bad. But then if you changed it to 8, when I kind of was tinkering, and this goes into experimentation, right? Measure. When I changed it to 8, performance dropped quite a bit. So
back it goes.
Yeah. So it's a very close balance. It's walking a very thin line. You can optimize things to work really well in these situations, but once you go a little too far, then you start hitting other contention, right? And that really breaks down to like that CPU task scheduler. And that's actually why I did that in that article, is to kind of show sometimes things don't always work out when you just add more numbers.
Yeah. So by messing with the worker threads, you were able to get it to go from a little under 3,000. You added another 2,250. So not quite doubling, but still quite good. And then the other thing you said is like, maybe some of these connections are going to last for a long time, or they're sort of backed up. Like, what if we let it accept more connections? And this is important for requests, but it's super important for like really large files, I would imagine, or even lots of them, people downloaded them, or even like WebSockets, these persistent type of things.
Yeah, exactly. And that's exactly it, right? Sometimes, and actually in this case, I believe it was a simple REST API. So there wasn't really a whole lot of like static connections, but you're right. That is a big performance increase when you have those long-lived connections. And sometimes, that's letting Nginx do some of the work. let Nginx kind of handle that connectivity by increasing the number of connections per worker. If they're very fast requests to the downstream application, you can actually kind of leverage Nginx handling connectivity with the end client and through the process very quick. So by making some changes, I think in that case, like I changed it to like 1024, for example, it went up to like 6,000 requests per second, which was
exactly
a huge improvement. It's really cool. Now, another thing in that kind of worker space is to look at the number of open files, which is a very common Linux limitation that people run into. In Nginx, as it's serving static content, for example, or even just the fact that it has logging enabled as well, it's going to have open file handles. And by default in Linux, there's a limitation. I want to say these days it's 4096, but actually I think the Nginx default limitation is much smaller. I forget what it is exactly. I mean, I think in that example, all I really did was just upped it to 4096, which allowed it to have even more files open, which gave a little bit of a boost, but not too much.
Yeah, it was still really nice. I think it gave it like 300 more or something about it. Yeah, which is cool. But the other thing you can do is most web workloads are hitting a number of files, 10, 50, 100, or 1,000. But after that, right, how many unique static files do you have in most situations? I know there are some that there's tons, but most sites, they've got their CSS and their images and whatever, and it's mostly shared, right? So you can also tell it to cache that stuff, right?
Yeah, you can. I would say one caveat, though, is just because you only have a certain amount of files doesn't mean that process isn't opening other files. Sometimes there's things like shared libraries that it opens, and all of those count as well. And some, even like sockets and things like that, they all kind of count towards limitations in the OS. But in regards to caching, that's actually pretty cool. There's some options with Nginx to do like a open file cache, which allows you to increase the default amount of cache for open file handles. So Nginx will open up those CSS files and those HTML files, like you were saying, and it will actually load them in memory. So that way, when you get a request, even though it's a file on the file system, since Nginx has it open and it's cached in memory, it doesn't have to go to disk for access of that, which makes it a lot faster.
Yeah, just serve it straight back out of memory. That's awesome.
Exactly.
So in the end, you were able to tune it, Nginx, just on its own bit from 2,900 up to 6,900. That's a serious bit of change by just tweaking a few config settings. And then you did the same thing, something similar on the uWSGI level. And then, of course, you could, tweak your architecture as well. But just making the stuff that contains your app go that much faster, that's pretty awesome.
There's another article that I wrote about kind of benchmarking Postgres. And I had a similar experience there. Is all I really did in that article was just adjust a shared buffers configuration. And what that is that's essentially a query cache for Postgres. And that change alone for the example I was given had a big performance increase. So, sometimes I kind of call these a little bit of low-hanging fruit because they're just little knobs you can change in existing systems. And sometimes those low-hanging fruit can be a really good first step.
None of those seem super scary, right? You just change some config files. I mean, if you mess up your config, you will take your website down. But, you just put it back. It's not super complicated, right?
The key is test before you put it in production, right? so as long as you're testing before production, then if you make a change and it doesn't work, then oh well, who cares, right? But
yeah, right.
Really, that's kind of getting into the measuring, establishing your baseline and measuring each little change and how they interact. That's real important. So yeah, that way when you go to production, you know exactly what you're changing.
Yeah, that sounds good. So we're just about out of time for our conversation here, but I did want to just ask you, how do things like Docker and Kubernetes change this? Do they just make it more complicated? Do they simplify it? What do you think containers mean around this conversation?
They simplify some things, like when we're talking scale out type approach, it makes it real easy to spin up a new one. I was kind of thinking when you asked that question, I think of some of the challenges I've ran into with those. One thing that I've run into with like Docker is if you just pull down a service and use that service out of the box without changing it, you're going to get kind of a default performance. So by using a Docker package, a lot of times you kind of forget about all those little knobs that you have to turn in order to get it fast and performant. And then another area that kind of goes into is Docker it has some services as well that things run through. And Kubernetes is a big example of this. So with Kubernetes, you have a software-defined network, right? So if you have like a cluster, and let's just give kind of a scenario, for whatever reason, you had, half your cluster on one side, half your cluster on another, and there's a network latency between getting to that other half. With Kubernetes and services, you would have your traffic land on any host within that cluster, and then that software-defined networking is responsible for moving that request to the appropriate hosts that might be running that service. So if there's some latency in there, you can actually start seeing that, and that's actually very obscured away once you start getting into that area. It's hard to kind of pin that down because that's so far removed from what you're doing in your application that can actually be pretty tricky. Plus the fact that you have to go through that software-defined networking means you're taking some penalties there. But again, it's probably worth it.
Yeah, probably. Very, very interesting. All right. Before I get to the final two questions for you, you said that we were talking before we hit record about an open source project that you're working on as well. You just want to give a quick elevator pitch for what that is so people know about it?
Yeah, absolutely. So automatron is the open source tool that I've created. It's kind of a second version of something called Runbook. I launched a open source project called Runbook, and things happened where I was like, I need to redo this and start fresh. And that became automatron. And really what it is it's kind of like if Nagios met IFTTT. So where you have these health checks and they monitor whatever you tell them to monitor. The health checks are really just executables. What it'll do is it will SSH to the remote server, to the monitored system, run that health check, and based on kind of the Nagios return codes, it's either good or bad.
Right, like SSH in and ask for the free memory or something like that.
Yeah, exactly. And if it's bad, if you beyond a threshold,
if it's zero.
Yeah, exactly. Then really the exit code would indicate a failure. And that exit code will actually trigger an action to take place, which is, again, SSHing out to a system and then executing either a command or a script or something like that. And this is all built in Python, and it actually uses Fabric very heavily, which is a really cool SSH command execution wrapper. It's very cool. I'm a big fan of it. And I used it very heavily there. And it's kind of a cool little side project. And really what it's there for is I hate on-call, and I really wish it would go away. And this is one of my ways to hopefully help people make it go away.
Could a machine just go restart the web server process and just not call me?
Exactly. Or, in some cases, when you've kind of designed your environment well enough, you could just maybe reboot the box and who cares?
True.
At a certain scale, is it worth finding the root cause of a single issue, or is it more worth finding the root cause of continuous issues? And that's kind of one of the real philosophy changes that kind of project brings is, in my opinion, at least, it's worth fighting, more frequent and reoccurring problems, and just one-off problems are not worth it. Just restart the thing.
Yep. That sounds awesome. All right, cool. So people check that out. We'll put it in the show notes. All right, last two questions before we go. If you're going to write some Python code, what editor do you use?
Right now, it's Vim, screen, and syntax highlighting. That's it. I'm kind of weird, I believe. But that's where I feel comfortable. And I think that's all those years in kind of operations has led me to that.
Yeah, cool. And then notable PyPI package. You already called out Fabric, right? That's pretty awesome.
Yeah, Fabric is an awesome one. I actually wanted to call out, since we're talking performance tuning, Frozen Flask. Now, it's not one that I've used personally quite a bit, but the whole concept is it allows you to pre-generate static pages from a Flask application. So it's really cool.
Ooh.
And the the real awesome thing that you can do is you can kind of combine that with certain like Nginx rules to where it'll pre-generate the static HTML, and then based on regular expressions in the paths and things like that, you can have Nginx serve that static HTML without having to go down further in the stack. And that's real cool because you can use Frozen Flask to still kind of keep that all within your Python application. And it's really just at runtime, it'll generate that static HTML, it'll freeze it, and it's just Nginx configuration from there takes it away.
Yeah, that's pretty awesome. So you get the dynamic sort of data-driven bit, but then you could just freeze it, if you will, like turn it to static files and then serve it through that way. That's cool.
Most web applications, you have static pages and dynamic pages, and really using it to establish those static pages and pre-generate them can be a big benefit in kind of production workloads, not just from a performance perspective, but cost of what it takes to run it as well.
For sure. That's really interesting. And sometimes those sort of landing pages and main catalog pages, that's where like really the busy traffic is anyway.
That's pretty much my use case that I've used things like that. I haven't used that one in particular, but I've done some things like that where I just prefetch pages and save the HTML for, nice. Yeah, it was hacky, but it really helped keep things slim. So it works.
That's awesome. Cool. All right, Ben, final call to action. People are excited. They realize like there's a few knobs that make their code much faster. What do you think? They should start by reading your 2 articles about optimization?
And really just don't be afraid to just jump right into it. Even if you don't know how something works, sometimes just turning that knob and then figuring out why it works is a real benefit. But for kind of self-promotion, for sure, check out those blog posts. You can kind of follow me on Twitter. MadFlojo is my handle. I have quite a few posts out there and lots of different stuff and lots of different kind of areas, but that's definitely a good start.
Yeah, people should check out benkane.com/archive.html because you have a ton of awesome articles there. We just chose a few to speak about.
Awesome. Thanks. Yeah, I have tons of stuff, whether it's Docker related, performance tuning. One article I wrote is kind of building self-healing environments using things like Salt and just some Python code, which is
very cool. Well, thanks so much for sharing your experience. It was great to chat with you.
Awesome. Thank you. Thank you for having me.
You bet. This has been another episode of Talk Python to Me. Today's guest has been Ben Kane, and this episode is brought to you by Rollbar and GoCD. Rollbar takes the pain out of errors. They give you the context and insight you need to quickly locate and fix errors that might have gone unnoticed until your users complain, of course. As Talk Python to Me listeners, track a ridiculous number of errors for free at rollbar.com/talkpython-to-me. GoCD is the on-premise open-source continuous delivery server. Want to improve your deployment workflow but keep your code and builds in-house? Check out GoCD at talkpython.fm/GOCD and take control over your process. Are you or a colleague trying to learn Python? Have you tried books and videos that just left you bored by covering topics point by point? Well, check out my online course, Python Jumpstart by Building 10 Apps at talkpython.fm/course to experience a more engaging way to learn Python. And if you're looking for something a little more advanced, try my Write Pythonic Code course at talkpython.fm/Pythonic. Be sure to subscribe to the show. Open your favorite podcatcher and search for Python. We should be right at the top. You can also find the iTunes feed at /iTunes, Google Play feed at /play, and direct RSS feed at /RSS on talkpython.fm. This is your host, Michael Kennedy. Thanks so much for listening. I really appreciate it. Now get out there and write some Python code.